Welcome. My name's John Huth, and I'm your host today. I'm a Radcliffe Ventures faculty member, which means I help Radcliffe do a variety of programming here, most notably the science programming. This is the last in a series of lectures on the ocean. This is a thematic year about oceans. We had a science symposium on oceans in the fall, and we've had a number of topics that are pertinent to oceans throughout the year. This is the last of these. The title of this talk is More Oceans, Less Plastic by Anna Cummins, who is the co-founder of the Gyres Institute. And because I guess I'm introducing, I get to blather on just a little bit, so you'll have to forgive me, okay? So this is a topic near and dear to my heart. I'm a sea kayaker and a member of the Maine Island Trail Association. We have 3 members over there, and every year we participate in a cleanup of some of the main islands. So we go out on a skiff, get a bunch of garbage bags, we scour the ground, and what we see is a ton of plastic. I mean, you wouldn't believe how much there is. Lobstermen, they will take a bleach bottle, they'll rinse off their deck, and they'll just toss it out in the Gulf of Maine, and or oil bottles. And this is most of the stuff that we clean up. And it's rather amazing because they don't even realize that they're tossing this stuff where they earn their living, right? And it's a bit unfathomable, but it says that they probably think that it's an infinite resource, and it's not exhaustible. So that's one thing that I found of interest. Another one was there was a recent paper that was published that was in the New York Times about the discovery of large amounts of plastic in the Arctic Ocean, that are being transported there through a kind of current called a thermohaline current, which is not a typical surface current, but has to do with salinity. And I should mention that this was found through the work of partly Chris Bowler, who I don't think is here, but he's a fellow at the Radcliffe Institute this year, and he runs an expedition vessel called the Tara that found this. And so, as you'll probably hear, there are 5 subtropical gyres in the oceans. However, there is a 6th gyre called the Beaufort Gyre in the Arctic Ocean. So you might have to change the name to... Is there 11?
Yes.
Okay, well, I stand corrected. This is why I'm here to listen, and I should just keep my big mouth shut. Thank you. Okay, so Anna, she's been spending 20 years studying and protecting the oceans, an undergrad at Stanford, master's from Monterey Institute for International Affairs, a Sustainable Communities Leadership Fellowship. In 2009, she founded the Gyres Institute with Marcus Erickson, and since the founding, she spent a huge number of trips, and one in particular that I look forward to hearing about is on a junk raft out of Hawaii. So without any further ado, Anna.
Well, thank you so much. Thank you especially to John and to Linda and all the people, all the staff who made this possible and brought me out here today. I wonder how many people can say that they were given the floor at one of our nation's most prestigious institutes to talk trash. But in all seriousness, at Gyres, we really appreciate the opportunity to share some of our research with your community and hopefully not inspire guilt, but hopefully inspire new thoughts and ideas about solutions. So when I first was exposed to this issue of plastic pollution in 2001, it was barely a blip on the public radar. I was a student at the time at the Middlebury Institute for International Studies in Monterey, California, which is known as a hotbed for marine conservation around the world. And it was at this time that I heard a lecture in 2001 from a man named Captain Charles Moore, who is a hero in my world of plastic pollution. He was the first to really go out into the gyre and bring this to the public's attention. But what's really interesting to note is that the research in the literature on plastic predates Charlie Moore's work by decades. Some of the first reports and observations about plastic impacting marine life date back to the 60s and the 70s, the first major publication in Science magazine in the early 70s on plastic in the North Atlantic. But as never happens in the academic world, these studies pretty much sat on a shelf, oh my goodness, sat on a shelf gathering dust until Charlie went out and gathered the first samples, brought them back, samples like this, and media really began to pay attention. So that was in 2001. I left this lecture absolutely horrified by what I was hearing, both by the content, but also by the fact that no one was really talking about this. In my graduate program, nobody knew about it. So fast forward now, 16 years later, there is a global movement now around plastic pollution. Major institutes from the Ellen MacArthur Foundation to the United Nations to major corporations like Dell and Unilever, people are now paying attention. There is a movement called the Break Free from Plastics movement, which now encompasses more than 800 NGOs. So there really is some traction now, and the awareness is getting out in a big way. We've had federal legislation passed and lots of wins. But at the same time, as the movement grows and as more public pay attention and as there's pushback from the community, the opposition is right there getting equally strong. To give you an idea of what we're up against, in 2014, we produced around 311 million tons of plastic, and those numbers are expected to triple in the next 50 years. So we have a long way to go, and some of the same interests that serve the most to profit by this are the same ones that are using, at times, some pretty dirty tactics to fight us. So, with that, I wanted to also mention that we're now seeing new signs of this opposition between industry and the environmental movement that date back many, many years. But before I go further, I want to do something that parents, especially newly enamored parents, do a little too often, and that's share photos of their little ones. I've managed to include her in every presentation I've given for the last 4 years, so thank you for indulging me. But to me, she represents what's really at stake for the next generation. What sort of quality of life will we expect for the next generation? I love bringing her to nature. I especially love bringing her to the beach. And I wonder how I will explain this to her. So anyone who's been to Los Angeles might recognize this beach. This was the same beach where I used to play as a child. You can see the Santa Monica Pier in the background. Now, it normally doesn't look like this because it is a very popular tourist attraction, and immediately after a big rain, the sweepers and trucks will be out there to make sure that the public doesn't see this. And as a kid on this same beach, I would go and wander around looking for seashells and rocks. Today, I cannot walk this beach, or really virtually any beach that I've been to anywhere in the world, without finding trace levels of plastic. Now, we've, with 5 Gyres, had a chance over the last 8 years to conduct 17 expeditions around the world's oceans, collect over 600 samples, and I have a few basic observations I wanted to bring with. And that is, where there is seawater, there is plastic, which is a pretty remarkable thing to be able to say, given that plastics have only really been popular for the last 100 years. Of those 600 samples I mentioned, only 2 have come up free of plastic. And this was at a time when we weren't using high-tech research equipment to look for microfibers or nanoparticles of plastic. Second, that plastic pollution is a design flaw. And I think this is really important messaging. I'm going to share solutions later after I horrify you with all the gory bits. And it's important to come back to the messaging. How is the messaging about plastic being portrayed to us? Who is responsible or should be responsible for plastic pollution? Third, and this kind of goes hand in hand with plastic pollution being a design flaw, and that is that solutions must begin upstream. We've taken this material, fossil fuel-based, incredibly valuable, and we use it to make things that we throw away after one time. And that not only makes poor environmental sense, it makes very poor economic sense. So how did we get here in such a short period of time? I like beginning with this image because this really encapsulates our thinking about plastic. So this was the cover of Life magazine in 1955. This article was titled "Throwaway Living." And the copy in this article said, the objects you see flying around in this picture would normally take 40 hours to clean, except no housewife need bother, because we can just throw it all away. Now, we talk today about where is this place called away. Something I found recently, after showing this photo many, many, many times, is the cleanup that happened after this photo, which I think is equally fascinating and prophetic when you think about it. Because this stuff doesn't just disappear into thin air. It all has to go somewhere. We began seeing evidence of this as early as the 60s and the 70s. And no sooner did the first examples of plastic pollution littering roadsides start to become an issue, when a trade group came into being, a nonprofit group came into being called Keep America Beautiful, with funding provided by Coca-Cola and Pepsi and some of the same interests that really wanted to keep us from staying using a reusable, refillable system and moving to disposables. One of their first big, very successful ad campaigns, I'm sure many people here will recognize. And I want to show this photo not to suggest that this didn't have a great impact, because there are a lot of statistics about how litter abatement really improved. People were littering less after this campaign. But coming back to messaging, I don't know if you can see in the bottom right-hand corner, it says, people start pollution so people can stop it. And that messaging right there diverted attention from the system, that we were switching from a reusable system to a disposable system. Instead, it put the onus of responsibility on the public. It's a people problem. It's people littering. It has nothing to do with design. And herein lies a big part of the problem that we're still facing today. Now, starting in the 50s, we saw an explosion of plastic being produced. It did start fairly innocently, in that some of the early prototypes for plastic came from a response to things like precious resources being overused, ivory from elephants, and shellac, and rubber, and all of these different things. And then we saw a boom during World War II, a boom for plastic production. And that, coupled with a lot of messaging about how we needed to stimulate the economy with lots of consumption, was the perfect marriage for plastic and disposable plastics to come into being. So you can see this skyrocketing of production to, I mentioned before, today, 311 million tons of plastic expected to double and triple in the next 25 to 50 years. But what has not kept pace with this extreme explosion of production is our ability to recover and recycle. And there's a lot to say about recycling. But starting there, so out of that big number there, around 78 million tons of that are for packaging. Of that, only 14% is recovered. And I'm not going to say recycled. Of that 14%, only 2% is truly recycled in a closed loop system. So where is the rest going? It's going to landfills, it's going to incinerators, and it's being leaked out into the world's oceans and the environment. And that leakage is where I'm going to focus for the next while. That's really where our focus with 5 Gyres has been for the last 8 years or so. I saw this in a big way for my first time when I was on the Big Island of Hawaii. Has anyone ever heard of or been to Jungle Beach or Camilo Beach? Perhaps seen photos of it? Well, this is a unique beach in that it lies right in the heart of where a lot of currents that make up these ocean systems just bring lots of debris. And it used to actually be a foraging ground for islanders looking for logs and things like that. As I walked around this beach, it was like looking at Walmart washed ashore. You could find pretty much everything that you needed. And as I looked at the writing underneath a lot of objects here, shampoo bottles and detergent bottles, I saw writing in Spanish, English, Korean, Japanese, and Chinese. So this is literally washing up from the entire Pacific Rim. I would venture to guess that very little of this is coming from local islanders. And it's not just an environmental, ecological issue. There's also a human rights component here and a social justice component. As you see, I'm sure many people in the world have had a chance to travel to some areas that don't yet have infrastructure to deal with all of this waste. And here you can see a young boy in Manila in the Philippines. This river here is so choked with plastic you can't even see the water. And he's looking for anything that he might find that has some value. So here we can look to really the waste picker, this informal sector, to inform what things really do have value. So going back to the oceans, there are 5 subtropical gyres, 11 gyres total, but I'm going to show you a current modeling study that really shows how currents in the ocean travel. And this study was conducted by some scientists at NOAA using various modeling, computer model simulations to figure out where do drifters travel and accumulate over a 20-year period. So I like to tell people to imagine any one of those squares is an object, and you can track it around the oceans for the next 20 years. Half a year, 1 year, 3 years. You can see also how quickly the currents from Japan are making a beeline for the United States, and then others sort of getting up into that other gyre, the Aleutian currents. 10 years. So in 10 years, a single object can travel from California all the way to Japan and back. And in 20 years, it starts to pool in these concentration zones that we used to call garbage patches. And we're now referring to it as more of a smog, and I'll get more into that. So you can see here the 5 subtropical large gyres in the world. Now I want to focus a little bit on what are the impacts of taking this non-biodegradable fossil fuel material and saturating our oceans with these products. So entanglement. Now, as I mentioned before, some of the studies on entanglement were first reported back in the 60s. So this has been going on for a long time, and we're only now really beginning to wake up. This snapping turtle does have a happy ending. She was found outside of the swamps of New Orleans, so common snapping turtle, and a young boy found her. So for the young people in the audience, you guys can really make a difference. They brought this turtle to the Audubon Zoo. They named her Mae West for reasons that some of us will understand. And they were able to cut that ring off, and she did survive. We brought her back to Los Angeles, and she's now at a wildlife rehab center where children can see her, because she really tells a story about how even the small stuff can have devastating impacts. And ingestion. This is the other big way that plastic can affect marine wildlife. Many different species that feed and forage in the gyres are now increasingly finding our waste competing with their natural food source. And the numbers are stark. These are likely conservative estimates on how many marine animals are impacted. Today, it's roughly over 600 species, and the numbers are probably increasing. I do want to show you, though, that it's not just marine animals, and I brought something to illustrate that here. So my husband, Marcus, who co-founded this organization with me, had a chance to go to the deserts outside of Dubai 2 years ago, visiting some of the same places where, as a combat veteran, he served in the Gulf War and saw a different side of the whole fossil fuel issue. He brought this back along with 5 others. The one I wanted to bring was so large that I couldn't carry it. This was inside the stomach of a camel. I'll show you the larger one. So there are now so many examples of this. The first one that was sent to us we thought was maybe the anomaly, but we have 5 of them now, and according to some camel researchers, they're at the largest camel center in the world. When you find a carcass of camels today, you inevitably will find plastic in their stomachs. Plastic bags, plastic packaging, ropes. Why do they eat it? They may be attracted to food residue, or maybe it mimics something that they might naturally eat stuck in trees. It looks like leaves. So the point is that this is a marine issue and a terrestrial issue. So I had a chance to see this firsthand in 2008. I had been haunted by this issue since 2001, and I finally got my chance to join a research expedition across the North Pacific from Hawaii all the way back to Los Angeles. And what we saw day after day after day were samples that looked like this. This is actually a sample from that very journey. Mostly broken down confetti mixed in with a lot of marine life. And when people talk about the island the size of Texas, to debunk that, what you see in here, it looks like maybe a handful of confetti. We collected over an area maybe 2 nautical miles inside. So it's incredibly diffuse, very spread out. But it was what we saw at night that really struck me. We collected samples during the day and at night our samples were full of life. We have the largest migration of any species in the world in the oceans every single day, creatures coming up to feed on zooplankton. And now there is so much plastic in their feeding grounds that this is what we're seeing. This is a myctophid, also called a lanternfish. We brought over 600 of these back to land and found that roughly 1/3 of them had plastic in their stomachs, along with the zooplankton they should be eating. Scripps has also done a study like this, and they found 9%, so discrepancy is probably due to methods and how these fish were collected. But the point being, we're seeing plastic in the stomachs of fish that are extremely important in the food chain. These fish make up 60% of the ocean's fish biomass. And why we know this is a problem is that plastic in the oceans can absorb contaminants at very high concentrations. Things like PCBs and DDT, flame retardants. Chemicals that are hydrophobic, won't mix with water, but oleophilic, they'll stick to oily substances. And a single particle of plastic, the size of a lentil, can have up to a million times higher concentration of these pollutants than the ambient seawater. So this was a pretty profound realization for us. Two things happened on that trip: seeing the food chain impacts, and then also one day when Marcus, who I had known for a few months, fished out a piece of derelict fishing gear on that voyage, made a little ring, and proposed right there. And so that was how our personal and professional collided together. But he had one big adventure he wanted to do before we got married, and that was to build a raft out of plastic bottles and sail across those same currents and use that as a way to try and draw new eyes and ears to this issue. So there is Junk. That's the boat that we built. Took 2.5 months to build it. It took him 3 months to sail it. He often quips that he could have walked faster to Hawaii than sail in this boat. We collected 15,000 bottles from all over Los Angeles and had school children all over the state helping us with the materials. And the point was to ride those same currents that would take any drifting object from California out to Hawaii. Now, it didn't go as smoothly as we expected. It ended up taking 3 months instead of 6 weeks as we had predicted. They ran really low on food, and they had their worst storm on day 4. So I'm going to show you a couple of clips from that voyage, including what happened during that storm was that all the labels on their canned food got washed off. And the last video shows a more sobering look at the food chain impacts that I spoke about.
The ocean stripped all the labels off our cans. They got rusted. Now we got to eat them. It's all beans and corn and peas.
Come on, corn! Give me corn, give me corn, give me corn, give me corn, give me corn. Corn! Beans!
One more? Hey, let's see what it is.
We have the best, go for the best before. More beans.
No wind. We're completely becalmed today. There's no wind whatsoever. So we're just going to fish and eat. Hey, fishy, 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 fishy. Oh, there he is. Right now.
Lunch.
We are now skirting the edge of the North Pacific Gyre, roughly 1,000 miles east of Hawaii. And we're finding lots of plastic on the surface of the ocean. It's mostly small fragments, blue, green, white, and black, among many different kinds of zooplankton. Everywhere you go in the North Pacific Ocean, we find plastic. So I filleted this fish, thinking we're going to eat it, and here's what I found. It's full of plastic. This is the whole reason that we're out here, to bring this to your attention. The plastic isn't benign. The fish won't pass it. The plastic is full of persistent organic pollutants, things like PCBs, DDT, PAHs, things that are known human carcinogens and endocrine disruptors, things you don't want in your body, but they're in the fish that we eat.
I don't want plastic in my sushi.
So that was a very long summer for the fiance back on land. I was mission control and doing the weather reports and raising the funds back on land. This is what really shocked us, because we'd seen plastic in the stomachs of these small fish, those myctophid fish that I shared before, but this was the first time we'd seen plastic in the stomachs of fish that people would normally eat. Marcus didn't end up eating this one because of what we know about that transfer, that plastics absorb contaminants and that those can then desorb into the fatty tissues of fish and other organisms. But the science is going smaller and smaller on this to where we're now seeing fragments of plastic in the bodies of zooplankton, very important at the base of the food chain, and even nanoparticles of plastic inside the circulatory system of mussels and clams and other bivalves. And there have even been studies looking at common shellfish eaters and seeing the sum total of microplastics that they're ingesting because you eat the whole organism. You don't take out the stomach. Which brings up the question, what impact is this having on you and I? And the science here still needs a lot of work. There are a lot of points in that puzzle that can be proven, but looking at the whole link to see how are humans affected by plastic is challenging still. What we do know is that there's enough evidence to suggest that we proceed with caution. I was personally interested in this after Marcus and I got married and thought about having a child. You saw the results of that. She's healthy and everything came out fine. But when we took a sample of my blood and sent it off to a lab to be sampled for contaminants, we found all 4 contaminants that we were looking for. We were finding PCBs, DDT, PFCs, and flame retardants, higher levels of flame retardants. And it was really interesting when I got those studies back because a toxicologist helped me color code them for where I fell on the national spectrum. Green for good, orange for so-so, and red for not good. And I was green for 3 out of the 4 contaminants. And at first I celebrated. It was almost like getting good grades back on an exam. But then I thought, this is just crazy, that this is the new baseline. This is the new normal, that every single one of us has these contaminants in our body, and that the flame retardants were, slightly higher, being a Californian. Now, again, we have so much that we don't understand about this. It's very difficult to say that there's a cause and effect. We also don't know how do these chemicals interact with one another inside the human body. There are studies looking at those chemicals in isolation. But again, my personal feeling and a lot of sentiments shared by people in this field are that we have enough information to suggest that we proceed with caution, that the burden of responsibility for proving that these chemicals are safe should be put on industry and corporations and should not be placed on the general public. So these ideas were swirling around for us when we decided we need to get more information about this issue. We'd seen a lot of research thanks to Captain Charles Moore about plastic in the North Pacific, but there was 0 research on plastic in those Southern Hemisphere gyres. So this was our inspiration to launch a new organization and sail around the world looking at this issue of plastic pollution. So part of what we did was invite the public to join, and this is something that we still do, is invite other scientists, filmmakers, students, teachers, artists, musicians, and even heads of companies, including people from the industry, to come with us, roll up their sleeves, get their hands dirty, participate in the science, and then go back to their communities to be ambassadors. So I'm going to share another short video, very low production quality. This was iPhone and laptop on a boat. But this gives an idea of what it's like to be out in the middle of the ocean and see evidence of plastic contaminating some really remote regions. This was also our honeymoon.
Let's bring it in.
Some larval fish, sargassum, and little plastic particles. Look at that.
We're in the middle of the North Atlantic Gyre, also called the Sargasso Sea. It's called the Sargasso Sea because of sargassum. It's a kind of seaweed that filled our nets. But it's also full of small particles of plastic. What you got, Anna?
I see one.
It's a mouthpiece, I think, for a boxer. It's got some barnacles, some sargassum. This is 45 minutes of scooping through another windrow in the middle of the Sargasso Sea.
Yeah. Cool.
It's gonna flop out. Yeah. So we just pulled out this plastic bucket and we found a triggerfish inside that's so big that it looks like it can't get out.
I think his entire life is in this jar. Here's a triggerfish. Look at these teeth. Now look at this plastic bottle. Now we find these all around the North Atlantic Gyre. Bits of plastics chewed on by marine life.
10 degrees to port, climb about 100 meters. Dun-dun-dun.
You know how gross that is?
Very salty. Probably pretty clean. So I could show hundreds of photos that all pretty much look like this. And this is a typical sample. This one is from the South Atlantic. You can see just this mixture of life, Portuguese man-o-war mixed in with these fragments of plastic that are impossible to really attribute to any source. We can't tell what product these came from, what country they came from. So coming up with solutions can be challenging when you're looking at microplastics. But when we took all of our data from all 5 gyres and other hotspots around the world and paired it with data from 7 other scientists from regions around the world, we were able to come up with the first global estimate of plastic floating in the oceans. Now, this is very different from plastic entering the oceans, but this is what we found. Roughly 270,000 metric tons, made up of 5.25 trillion particles. And that, I think, is the important part. Who can visualize 5.25 trillion particles? None of us. But the point is that we can't go out to the oceans to clean up this problem. You can't skim the ocean of 5.25 trillion particles without removing so much life that you'd be probably doing more damage. We've got to go upstream and solve this problem closer to the source of the problem, which really, with any environmental problem, is a much more efficient way to go than cleanup. So this caused us to look at it differently. Instead of calling it a garbage patch, to call it a plastic smog. And we would apply the same kind of thinking to dealing with smog. You wouldn't clean it up with vacuum cleaners in the air. You would look at smarter emissions and smarter vehicles and smarter technology, better ways of design. Really, it's about design. So I want to share one example of how we can use science, in this case, to actually drive a solution. And we've been around the world looking at plastic in many of the world's oceans. And engaging people who don't live directly on an ocean can be challenging. Even though we all know that we need oceans for health, it can be hard to engage people to care about the coast if they're not right connected to an ocean. So that inspired us to go into the Great Lakes in 2012 to do the same sort of research. We spent 2012 and 2013 surveying all 5 of the Great Lakes in partnership with a great scientist from SUNY Fredonia, Dr. Sam Mason. And I'm going to share with you what we found. It wasn't at all what we expected. There are a lot of reasons why we should protect our oceans. They give us oxygen, they regulate our climate. Our oceans give us food. But what's really going on is we've turned our oceans into a plastic smog. We set out with a mission to research plastic pollution in all 5 oceans and then leverage those findings back to land to drive solutions.
We began in the North Atlantic, was our first expedition in 2010. Did the South Atlantic, across the Indian Ocean, the South Pacific, Chile to Easter Island, then up to North Pacific, finding microplastics in 21% of the planet's surface. Out there in the oceans, you really can't even identify the product because it's so broken down. I mean, how do you solve the problem with this? I can't point to a company, I can't point to a country. You got to get closer to land, into our rivers and lakes.
So we went into the Great Lakes doing the same research, the same methods that we've used in all 5 oceans.
There we could point to a country if we found something. Canada and the United States share those waters. We began to find these small, perfectly round little spheres, 1/3 millimeter in size. I'd never seen that anyplace else in the world. We had a hunch what they were, went to your local pharmacy. We got the facial scrubs, the one that even say Microbeads on the front, put them through a sieve, and there they were. They matched. polyethylene and polypropylene. It's a designed microplastic that goes on your face, down the drain, out to our rivers, lakes, into the ocean. The ocean's surface is not the final resting place for microplastics. It's settling to the seafloor, but it's also disappearing via the stomachs of animals that consume it.
A tiny particle of plastic the size of a microbead may look like a fish egg for many different organisms. Each one of these particles of plastic is like a sponge for contaminants, things like PCBs or DDT. Many different toxic chemicals can be absorbed by plastic in the ocean.
It's not just, one bird, one whale, and one fish. It's ecosystem-wide. They're eating all those plastics that go up the food chain back to you and I.
Whether or not we're a fish eater, we all depend on the oceans for health. Everyone has a local lake, stream, or river, or a watershed that they care about.
We can change our throwaway culture, the way we treat each other and the environment, and make it much better than it was last century. You can start with these facial cleansers and toothpastes. With these microbeads, these designed microplastics, which you cannot recycle at all, that's a design that needs to be changed. And that starts with us and our purchasing power. So zero waste your plastic footprint.
I'm going to skip the ending part. This is the sample that caused us to really pause. This one sample had more plastic than any of the ocean samples we'd looked at anywhere in the world. And now you know the rest of that story. We published those results in a peer-reviewed journal, and we thought that that would be enough. We called the vice president at Procter & Gamble and presented our findings, and what they said was, you need to do more research. Until you can prove that it's our products going into these waters, then we're not going to do anything. What was really interesting is that during this time, I found out that they've known about this for a long time. I found an internal document that was on the web. I saved it because it's not there anymore, basically saying that we recognize that these beads may be entering the aquatic environment and that we will probably need to do something about this at some point. Well, we didn't want to wait for that point. When we heard you need to do more research, we decided to go legislative. We hired an attorney in San Francisco. We co-drafted a bill, and we presented it in California. And in 2014, we came devastatingly close, lost by 2 Senate votes. Meantime, there was, Illinois passed a bill that everyone jumped up and down and got all excited about, and the same bill language was spreading from state to state to state. And what people didn't know is that this had a huge loophole that basically changed the entire spirit of the bill. Way down in the draft that very few people read, and in the definitions, how they defined plastic microbeads was any intentionally added non-biodegradable. So just by putting in that non-biodegradable piece, they opened up the door to put in bioplastics. PLA does not break down. PLA is one kind of bioplastic made from corn. It does not break down in the marine environment. It needs a high heat municipal composting facility, and even then, a lot of recyclers tell us that they don't want them. So that was pretty underhanded. We kept on with the battle, and what really made a difference in 2015 was getting a full coalition on board. And this is, again, just underscores the power of collaboration when lots of NGOs and policymakers come together. And students played a role here. These students at UCLA spent 3 months getting microbeads out of their student store, and that made a difference as we were fighting this fight in California. And then finally, after we passed the bill in California, this really laid down the momentum for a federal bill. And in the final days, weeks of 2015, President Obama signed the Microbeads Free Waters Act, a federal bill. So that was great news. But it's not enough. I mean, the plastic pollution movement celebrates these victories. We ban bags, we ban beads, but how are we really going to move the needle? And I want to share a couple more examples of solutions. How are we going to move towards a circular economy? And this is a concept that's now really getting traction. Instead of the way we do things now, we take products that are largely toxic in the environment. In a linear fashion, we produce products that mostly go to the landfill. And how can we change that idea? So we thought instead of picking off products one by one, we came together with a couple NGOs and produced a first draft of the ban list. And that was taking available data on coastal cleanups and waste management and trying to pair it together to come up with what are the 10 to 15 worst products that we just need to get rid of and redesign and back it up with good data. And one of the things we came to is a large majority of those were polystyrene. So this is a campaign that we are launching now, and a lot of groups around the world are really looking at polystyrene due to its high toxicity and due to its low recoverability and recyclability. And so this is just an example of what we're trying to do is we're trying to really facilitate people taking local action. And I think especially now with our current political status, it's reminding us of why we need to get even deeper involved in our local politics. And I was pleased to see that you have a number of bills here in Massachusetts, including a statewide bill to ban polystyrene. Another key part of this solution is really putting the onus, as I said in the very beginning, back on producers. So producers need to take responsibility for what happens to these products after they leave their hands. And there's a big fight here. You can see this map that shows where we have EPR as of 2015. And there seems to be a little bit of a desert in the United States. But fortunately, there are new bills being introduced now. There's a lot of opposition to this because they don't want to pay for the recovery of these products. But the fight is on, and I'm hopeful that this will happen in the coming years. Better design. How can we engage corporations in voluntary design? No one wants to spend 5, 10, 15 years fighting these legislative battles, which we'll continue to do. But when companies like this is a product that Rainbow Light put out, it's 100% post-consumer recycled plastic. And if we can incentivize the recovery of that, that's a great place to start. I came across this recently. It's just in the concept phase, but the idea being create packaging that when you're done with a product doesn't exist anymore. So this concept of disappearing packaging, this is one example of where the package is the product. This is a thesis project from a student. I'm really hoping that this will come to fruition, but this is the kind of thinking that we need really to get out of our packaging dilemma. Better systems. Can we come up with new systems in how we deliver goods? For example, sharing. This is a project in New York to the left. Not only is there a bike share happening here, but there's a vessel share. The company's called Vessel. And the idea is you go to a coffee shop, you pick up your vessel, and you can return it at the next coffee shop. Because we are all busy, forgetful people. We don't always remember. Can we come up with new ways of doing this? Same thing in Portland, where this similar concept with to-go-ware, with to-go packaging, where you can pick it up at one place, return it at another, and get rid of all of that packaging waste. And refillable, of course, coming up with new ways that we can avoid packaging entirely and just bring in our own containers and get our goods. Some post-consumer examples. Again, none of these alone are going to move the needle, but together, if we can come up with more creative approaches. To the left is a company called Borreo that are taking back fishing nets from all over the coast of Chile and moving on to other countries, grinding it up and turning it into products like skateboards and sunglasses and other durables. On the right, I put an example from a bigger corporation that I haven't thoroughly vetted, so I don't yet know how they're defining beach plastic, but this is a new product that Head & Shoulders has put out that is, in theory, 100% recyclable and made with beach plastic. More research there needed, but I did want to share this. And moving away from fossil fuels entirely as a feedstock, putting more research into truly compostable, biodegradable plastics that can be made from mushrooms or from algae or from shrimp or from compost. And the point being, we will need to get away from fossil fuels. And finally, getting the community involved, the power of artwork. So when we were doing the Microbeads campaign, Marcus, who's also a sculptor, created this piece called Anthropocene. It's pretty massive. It's a big steel ring with a Vitruvian man, 4 bikes, power, LED lights, and water that is inside, that is filled with microplastics. And the tubes of water go in and around the man's body to show this connection between microplastics and human health. And some artwork that you will see out in the lobby here, a wonderful group that you've heard a little bit about from the bow seat. We were so enamored of that photo on the right that we ended up using it to make a t-shirt, and I was really excited to see that the original is out in front. So I highly encourage you to go take a look. The student art here is phenomenal. And we all respond to different things, science, art, etc. Wrapping up here, this is an example of what you can do just on a personal level. As John mentioned in the beginning, reducing your plastic footprint. Our friend Lauren is able to save all the garbage she produces in a year in one small mason jar. So it can be done. And the role of influencers, a new campaign from Adrian Grenier and the Lonely Whale Foundation to try and combat our straw obsession, and the campaign is #StopSucking. So influencers can play a great role here. And finally, what we do in our home, on our campus, in our family can really have ripple effects that we might never anticipate. And that was the case with these students from a middle school in Los Angeles and Silver Lake. They decided to get rid of styrofoam trays. They created that long piece of all the trays that they used in 1 week. They got rid of the tray and they saved their school $12,000. This is a public school in 1 year. That got the attention of the district, and they banned styrofoam trays across the entire district. So again, these actions can have far-reaching consequences that we might never imagine. Now, I hope I shared some positivity in addition to the negativity. One final short clip from a wonderful place that I know Linda Cabot has been a big supporter of as well, called the Island School, where we had a chance to engage youth in really talking about solutions.
When I heard about the plastic problem, I never really noticed, but then when you actually start to see it, there's a lot of trash. Like, there's literally like trash right there. So
when I was a child, you'd walk on the beach and pick up shells. Now you pick up pieces of plastic. It's everywhere.
It's everywhere.
And this is where it starts to come back to you and I, because we're now seeing no shadow of doubt that plastic is getting into the food chain.
As plastic is out there floating in the ocean, it never biodegrades, which means
it never fully goes away. Animals are eating these plastics because they think they're food.
We go out and we fish for these fishes. When we eat them, these same toxins that the animals we're eating gets in our bodies.
It's not an issue we can ignore anymore because it's right in our face.
We're here at the 5 Gyres Sea Change Youth Summit. Sea Change stands not only for sea change, but also for science, education, and action, which is what we've been up to for the last 3 days.
We have an amazing crew of people like Jack Johnson.
We have Jordan Howard here.
We have Celine Cousteau.
We have David Stover here from Borreo Skateboards.
He uses old nets, like he recycles it and makes it into skateboards. I really thought that was cool.
We actually made some toothpaste, some environmentally friendly toothpaste.
My favorite activity was the storytelling exercise.
The kids started telling their stories, and then they started building on each other's stories. That's where we see activism spread like a grass bush fire, you know? That's what we want to happen at a summit like this.
I get inspired because I meet young people, like here at this youth summit, that say, I know it's a problem. This is what I'm doing. This is the one change I'm making. And the ideas are pouring out of these young minds.
Well, it's World Environment Day. We've collected a bunch of plastic pollution. You got some? And now we're taking a look at it, kind of seeing what we find.
This is the turtle bite.
Yep.
And this is like the triggerfish bite.
This is representative of one of the quadrants that we sift through the surface sand. So this is 1 square meter of beach.
Gotta get home, there's a garden to tend. All the seed from the fruit buried and begin their own family trees. Teach them thank you and please. Spread their own roots, then watch the young fruit grow again.
So yesterday, we collected a bunch of plastic pollution on the beach, and today, we decided to make a community art piece out of it.
So I try to understand what I can hold in my hand, and whatever I find my way back.
So one person can tell another, that person tells 2. 2 turns to 4, 4 turns to hopefully 4 million, who knows, you know, I'm optimistic. So we have to see the what? Change! See?
Change! I see change every day.
I see change in the way the world sees the future.
I see change when we take responsibility as individuals.
But I also see change in the youth.
In the Bahamian youth. I see change when a youth finds their voice and knows that they can be a leader in their community.
Things that our generation would have never dreamed of.
I see change in all of us. We all can make a difference.
Okay, thank you so much.